All right, so for tonight, we're going to do a couple things. First, we're going to start off by going over the solution to the activity from Monday's lesson. Then we're going to dive into the Mod 4 project, go over the requirements, and then get you started with a starter notebook and give you some time to kind of work together on the first steps. So to start, the activity from Monday's lesson, just to remind you, we were trying to decide which stock to invest to out of 3 stocks based on time series data for each one. So we had to build a model to fit each one and then use that to determine and make predictions on the next day to decide which one is best to invest in. So this is how I did it. I'll kind of just go through it here. Import your libraries, read in the data, and set the index as a datetime index. We'll give that a second to run. All right. So the next step is to create a list of data frames. And then I also just created a list of the stock names just so I could reference them later. So I go through the unique values in the name column. There's only 3 stocks, so it's just going to be 3. And for each one, I append the data frame that is that stock name only. And then I only append the closed column because that's what we're going to be using as our main value. And then I just add the stock name to my stock names list. So run that. And then just to show there's 3, there's the different stock names. So now for each one, I'm just going to plot them just to visualize what's going on. We can see some are noisier than others, but generally they all have increased kind of over time. And the most recent values, they're all looking like they're on an upward trend. So it's kind of hard to tell from here which one might be best to invest in. So for this next part now, we have to generate features for our model. So I chose here a test period of 14 days, 2 weeks. As we discussed Monday, since it's stock data, it's kind of hard to do a longer test period because all of these have changes that happened recently. So when you exclude that in your test data, then you're kind of missing out on that upward trend towards the end. So it's kind of hard to get good results that way, but that's just kind of the nature of stock data. So I went through and I added the month, the day, and the year. Because the data was by day for frequency, I could do all 3 of those things. So I added all of those here. Then the next thing, I take those month, day, and year, and for each one, I add a quadratic and a cubic term. Then I go through and I chose to do the 100 previous values. You could go up to, a year maybe. Kind of just depends. You can always play around with that number. So I went up to 100, added all those previous values, and then for each one, I added again the quadratic and cubic terms. So with all the features added, then I fit a regression model. And remember, this is for each stock data frame. So I fit a model, and then I'm storing a list of those models that I append the regression model to. And then I also created a new empty list for the stock data frames. So I have a list of the initial data frames, and then I also have a new list that has an underscore at the end. This one has the generated features in it. So for the next part, I'm going to generate forecasts on the test period. So it's repeating a lot of the above code. It's just doing it now line by line and for each stock. So I go through, if you guys haven't seen this zip, it basically takes 2 lists that have the same length and lets you kind of iterate down through. So for each pass through, I get the first model and then the first data frame, so on and so forth. So I go through each model and its data frame. I split out the actual values here. So just the actual values in the original data frame for the test period. And then I create an empty list for my forecast. Then I make a forecast data frame that's just an initial copy of the original data frame. And then I iterate through each row in the test period. And I basically have to calculate the values, generate the features just like I did up here. So I add the month, the day, and the year, the polynomial terms for those features. Then I add the previous values and the polynomial terms for those features as well. So with all of that, I have a list here that is basically one row of the data frame. And so now I can plug that row of data into my model and call predict on it to get a forecast for that specific row in the data frame. And then I replaced that row with the values that I calculated, and I continue on the data frame and basically repeat that for each model and data frame. And then I'm also going to plot the actual and the predicted, or the forecast here, and then calculate the mean squared error, put that as the title, and then also keep a copy of the forecast data frames. And then another thing I do here, just to give you an idea of the time, I'm gonna time this just so we have an idea for 3 different stocks how long this takes. So models is not defined because I probably didn't run this. And now I'll run this. It shouldn't take too long. All right, so here's the actual versus forecast. Now these look kind of bad, but you have to be careful. You have to look at the Y scale. So this is only within $4. So really, it's not that bad. The mean squared error is kind of low. This second one is a little bit worse. The mean squared error is $66. It is kind of off. But again, if you were to zoom out and see the whole stock, like before up here, it would not be, a largely significant error. And then kind of similar to the first one down here on the third. And that took about 4 seconds, so not too bad. So now for each of those models, I'm going to just look at the selected features that the lasso regression chose. So this is for the stock MMM, it shows these features, and then for this stock and this stock. So it shows different number of features and different features for each one, whichever just explains the values the best. So you can kind of look more into that if you want to try and kind of see what's going on. Previous 7 makes sense because it's weekly. You always want to think about, what the previous value corresponds to. So if it's days, then, 7 is going to be a week. 30 would be a month, things like that. All right, so now the last step is to predict tomorrow's price for each stock. So this is a little bit complicated. We didn't do this in the study group. This is kind of something extra. But so to do this, we need to have the date time that we want to predict. So if we go back up here to stock EFs, and we'll just grab the first one and then print out the tail because I want to see what the last date was. So the last date ended on the 29th of December. So tomorrow is going to be the 30th of December. So I make a date time object here, just so in my for loop, I can get the month off of it, the day of the year, stuff like that. It kind of makes it easier. And then I also need the index of tomorrow's date. So if I get the length of one of these data frames, it goes up to 3020. So I believe that's tomorrow's date. So that will be the index. That's the 3020th row. So I have that here just so when I go to get the values and the previous values, I know which rows to reference basically. So now for each stock, for each data frame in my stock data frames, I'm going to fit a new model. This is a final model that's trained on the entire data set. So not the test period anymore. We want to train it on everything we have to give the best prediction, especially the most recent data points, because that's going to be the most significant in determining tomorrow's value. And then like before, I'm going to generate the features that I've added. So the month, the day, and the year, and then the polynomials of those. I just did it line by line here, just so it's easier to kind of read. And then the previous values and the polynomial terms for those. And then with all of those, with that one row of values for tomorrow, I pass that into the model, get the prediction, and then I just store a list of basically today's values and tomorrow's values. So then it's easy to compare for each stock. So we'll go ahead and run this. It's only generating 3 predictions, so it shouldn't take too long. And then I basically throw everything into a data frame to make it easy to read. So we have our stock, we have today's value, tomorrow's predicted value, and then the change. So from this, it seems to suggest that stock GS is going to be the best to invest into. It's the only one that's actually going to go up in value for tomorrow, according to our predictions. So this would kind of be the end solution then. Does anyone have any questions on any of this?
Can you say again, when you were looking at the rows, like for tomorrow's date, you were looking at the last row to make a today's date would be 1 minus that? I'm sorry, I missed that part. That right there, tomorrow's date and today's date.
Okay, so tomorrow date, let's see if do I even use today date? I don't think I ended up using that down in here. Let me just. Yeah, so I didn't even need that. So I used tomorrow's date down here for the previous values. So for I in the range of my previous values, so up to 100, I go to the tomorrow's date index, and then I subtract I. So the first one I get the value, the previous value from tomorrow's date, so that would be today. And then 2 days ago from tomorrow, so on and so forth. Does that make sense?
Thank you.
Yep. Anyone else? This is very similar to what you could do on the Mod 4 project, so definitely keep this as a reference. Let's see. All right, so if no one has any other questions, we can go ahead and start on the Mod 4 project. If you want to open up the Mod 4 details, it's just in Mod 4 on the repository, and then it's not in a folder. It's just kind of in the main folder here. So if you guys want to follow along, it's the same thing that's on Learn, so you can pull it up there too. And first of all, I love this GIF. I don't know what it's from, but I want to find out. So if anyone knows, let me know. All right, so Mod 4 project should be no surprise. It's on time series. You're going to be looking at real estate data from Zillow, if you're familiar with that. Basically have data on homes. You can use it if you're buying, renting, or selling. So it'll have a bunch of different data on different zip codes in the United States. And so for this project, you're going to have to answer a simple question, which is, what are the 5 best zip codes for us to invest in? So in the data set, you're going to have zip codes for the entire country, basically. That's going to be way too many to kind of find the best 5. So one thing that you're going to want to start thinking about is how are you going to narrow this down? So this has you picture, you're acting as a consultant for a real estate investment firm. So that would probably be located in, one state maybe, or maybe a region. So you probably want to narrow it down some way like that. So deliverables, it's almost the same as the other projects. You need your notebook. You need a README, a blog post, and a non-technical presentation. So for some must-haves in the notebook, you need to be organized. This project has the tendency to get a lot messier than the other ones because you're just doing a lot more. You're working with so many zip codes. It's kind of a lot. So keeping it organized is going to be super important. You need to find a way to share your findings in a way that makes sense for the business. So, why are we going to invest in these 5 zip codes? Maybe say, what's the likelihood that we'll see like return on investment in these? some kind of business related explanation for your findings. And then since we're dealing with time series are really good for visualization. So you definitely should show some kind of visualization, maybe just for the final 5 zip codes. Something with your forecasts can be cool. You saw the one graph we did in the ARIMA lab, I think, where it shows kind of the confidence area in the gray on a forecast. That could be good to use here. I think this is an example of like a bad visualization. This is like all the zip codes and like their values over time and then the forecast. And obviously this is like impossible to tell what's going on. There's no legend, there's like a million lines, really hard to read. So don't do stuff like this. And that is kind of the basics of what you need to have. The executive summary, the PowerPoint and stuff, that's going to be about the same thing as usual. You just need to make sure you include those 5 suggested zip codes to invest in, and then an explanation of the metrics that led you to that decision. So does anyone have any questions on the requirements before we start looking at the data?
So there's no video this time?
So you're technically always supposed to record your non-technical and upload it. So yeah, that's like usual too.
Alrighty.
All right, so with that, if you want to move over to the Mod 4 starter notebook, we'll jump into this here. Oh, and actually, I forgot to include the CSV file, so let me upload that here, unless you guys have it already. Oh, and I cannot put it on GitHub, so you guys might have to get it from the LearnCo repository. Let's see if we can pull this up. All right, so yeah, it's on here. I'll post this in the chat if you guys want to download it real quick. It is a big file, so there we go. And it's just the Zillow data CSV. And you'll want to just put that in the same folder as the starter notebook. And if you want to just give me a thumbs up when you've got the data set downloaded. Is everyone able to get the data set? Juliet, do you got it?
I'm working on it. Give me a second. Well, you could continue. It's okay.
We're just going to read it in here just so you can see what's going on. So you've got region ID, region name. let me double check which one is zip code actually. So I think it's region name. Yeah, it would be region name. All right, so that's the first important thing. Region name is the zip code, not region ID. Because region ID is probably just when it was added to the Zillow system, and that's like the ID for it. So you have your zip code, you have the city, the state, and the metro, and the county. So you know exactly what area of the country it represents. The size rank, I think it's just ranked by the size, either the population or the number of homes. So like Chicago appears to be the biggest. But so now for the important data, the time series data, so you'll notice it's in a kind of a different format. This is technically a wide format. So you have each date as a column and then the values for each zip code. So this is like the, I think it's like the average listing price. I have to double check on the resource it gave, but basically the average listing price of homes in that zip code. So the first thing is that, you know, this is a different format than we've seen. Usually we have one column that's date and then the values. So we'll see how to work with that in a second. Let's just see how long the data frame is. Over 14,000 zip codes. That's a lot. You saw for doing like 3 stocks, it took like 5 seconds for the linear regression method, but you can imagine it'd be a lot longer for this many, and especially with doing ARIMA. So let's see how many for each state we have if we wanted to start breaking it down. So now you have options, you know, if you're feeling ambitious, you could go for California. There's maybe more money to be made in like California and New York, or you can choose a smaller state. So I chose a specific zip code now to look at. This is Columbus, where I'm moving in a couple days. So we'll just look at this record in particular and see how to kind of manipulate the structure of the date times here. So this is the county. So what I'm going to do is drop all the stuff I don't need. So all I want is the date time data. So I'm going to drop region ID, region name, all the way to size rank. You can always get this back just from the original data frame. So we're just going to drop it for now. So now all I have is the time series data, but the dates are the columns. So we need to do something about that. Well, lucky for us, there's a great function in pandas called melt, which will basically flip the columns to rows. So you can see what it is before. We'll just call melt on it, set it equal to itself so that it saves, and then look at it now. So now we have our date in one column, the value in the other. You'll notice there's not a number here. So basically Zillow doesn't have data for every date for every zip code. So you might see this for some of the zip codes. So basically all you have to do is drop those missing values, and you can just do it with the in place here. And now we have where the data actually starts in 2014. So now this, at least for this zip code, it would be all ready to go. You could make the index the date time, make it a date time index, and then you have your value column. So now I wanted to go into some suggestions about how to go about this. My first one, let's just go into the slide view here, is to choose a focus. So, you know, choose one state, one region, you know, maybe 3 states, one county, or maybe just urban areas in a state. There's a bunch of different ways you could break it down. Pick something that's interesting to you, and then, you know, make sure you know how many zip codes you're actually dealing with. The second is to make sure you do some exploration, you know, do the seasonal decomposition, look at ACF and PACF, just for some of the time series in your section of zip codes that you choose, just so you kind of have an idea. You know, you can compare them. Do they all have similar shapes? Are they all different? You just want to understand what's going on a little bit. And then you'll want to build models for just a couple of them. So here you'll want to test out a couple different methods. There's ARIMA and there's linear regression mostly. You'll want to kind of see what works for you, what works for the data set and the zip codes that you chose. You want to make sure you have like a good direction before you start doing this on 100 or more zip codes at once. So for building your models, kind of goes into the same thing. Time complexity is going to be a huge issue. Just to give you an example, other students who've done this project, at least for the ARIMA model method, have taken 5 hours to run for just one state. So it can be very time consuming. So before, if you're going that route, before you push the button to, you know, let it run for 5 hours, you want to make sure it's going to work. So definitely test it out on a small subset of the data. Make sure that everything's working fine, and then you can do it on the entire thing. And also, if you do it on the entire thing, make sure you save your results to file right after, just in case your computer shuts off or you lose it somehow. And to help you with determining and estimating how long stuff's going to take, here's just basically how to time yourself in Python. You import time, you set a start date, just time.time, and then you do something in a loop for a while, and then you just calculate the current time again with time.time, subtract the start, and that will give you the total seconds that have passed. So this took about 0.05 of a second. If we increase our range here, it'll take a little bit longer. So that took 5 seconds. So you can kind of, you know, plug in 10, 20 zip codes, see how long that takes, and then you can kind of extrapolate from there how long it's going to take with even more. So definitely keep that in mind. It'll save you a lot of headache, and it also helps to know when to expect it to be done. If you were just doing it for the first time and you had no idea it was going to take 5 hours, you might think it like was having an error or something if it just kept running. So you want to make sure you know like how long you're expecting it to run. And then you also want to decide on metrics to use. So you've seen us use a couple different things, train test split, done with like MSE, or you can do AIC and BIC. You can also research other metrics. There's a lot out there saying what's good and what isn't, especially for time series data. So definitely do some thinking about this and choose the one that makes the most sense to you. And then lastly, try to back up your final decision with some outside information. You don't want to necessarily throw only numbers at the business people. You want to give them, you know, some other reasoning of maybe why this is a good zip code. You know, maybe look up the growth in population recently. Maybe look at if there's like new companies that have relocated there, things like that, that might kind of make it make more sense why this is a hot area to invest in. And so that's kind of my main suggestions for you guys. So for the rest of tonight, I'm just going to kind of have it be open floor here. Someone can share if they want. You guys can kind of get started exploring, and I'll be here to answer questions. Does anyone have any now?
Matt, I do have one. So do we have to run the model on each individual state? Can there be a national model?
What do you mean national? Like on all the zip codes or?
On all the regions or all the other states?
I mean, you could run on the entire thing, but I mean, keep in mind it's 14,000 zip codes. So that might be a little constraining on your time, and depending on what method you go with and what kind of computer you have too. Most people, almost everyone who's done this project has narrowed it down to at least like a state or two.
Okay.
So if I'm going to pick New Jersey because that's where I'm from. So if I go there, if I do that, right?
Yeah, so that's 502.
Right. So I pick like a county. You said I could pick a county and see kind of all the zip codes that are within that county, something like that.
Yeah, so you could just pick like one county and see how many zip codes are in it. obviously you want like more than 5 because at the end you're going to have to pick 5. So it kind of depends on that. But
Okay.
yeah, pick like a region or two and narrow it down like in the best way you can. You could do, I mean, with 500, that is a lot, but you could definitely still do like the entire state if you wanted.
Okay. All right. Thank you.
So if I do on entire state, how can I narrow it down to zip code level?
So if you wanted to break it down here, so we could break it into Ohio. So DF state equals Ohio. So this is all the zip codes in Ohio. So by region name here, each of those are the zip codes. Metros are like larger areas, so they could have multiple zip codes. Counties could have multiple zip codes. Is that kind of what you mean, or?
I mean, if I melt the data frame and make a vertical one, make a long one, then each of my zip code will have like 200 something records, right?
Mm-hmm.
So if I model on state level, I'm treating all the zip code the same, I guess.
Oh, so you're saying like if like, because in this example, when I melted it, it was just 1. So you're saying if you melted and you did like the whole state, like how would that? So in that case, then like you have to kind of look at the documentation and I can help you with it, but you would basically have, this would be, you know, the zip code, and then you have another column where the title of the column is another zip code and all the values. So then when you're building your model, you could just go DF and then, you know, whatever the zip code is. So that each column code.
So do you mean that I need to build a model for each single zip code?
Yeah, yep. So each zip code is going to have a different time series, and like they're going to look differently. So each zip code has to have a separate model.
Oh, wow. So it's not just a state level, but zip code level.
Right. It's like the stocks, only it's zip codes. So each one has its own model.
Oh my. Can I use some metrics to narrow it down to some states before deciding to run all the states?
I mean, you could just choose a state to start with, like Juliet's going to do, like just pick New Jersey or wherever, and just decide, oh, a real estate company who only works in the state asking me to find which are the best zip codes to invest in.
Oh, okay. So I can do that. So the best 5 zip code in one state, right?
Yeah,
Not
yeah.
necessarily in the total US. Okay, good, cool.
Yeah, no, you're just given all the data, but it's up to you to kind of be creative and make it your own kind of question that you're investigating.
Oh, cool, I see.
Everyone else good with this? Kind of understand what you're doing? All right, I'm gonna stop sharing. I don't know if someone wants to share, if that would help you guys, or if you just want to kind of explore it yourself here at first.
Yeah, I kind of just want to take a look at first.
And actually, I have some examples to show you guys if that would help. So one
Yeah.
of the instructors recommended these 3 for being really good. So I haven't looked at them, so we'll just kind of go through here. So it looks like this person picked West Virginia, and they picked this specific region. So it looks like 5, 6 counties here. So they went ahead and mapped it. I think these are the 5 best zip codes. It's the 5 highest and the 5 lowest. Highest projected and then lowest projected. And then they just give their confidence intervals around that as like validation. And then they have a recommendation here. They did EDA. Let's see, this is by region. They did some research, the 2007 housing bubble crash. Let's see, model selection. So they did a SARIMA from stats models. It looks like they chose a yearly seasonal value. And then here it looks like they did their predictions with the confidence interval cone. So this is on the forecasting for their zip codes showing the increase. And then these are the worst ones. And then they compared states. And then this is just comparing overall West Virginia. So that's what they did. Let's go to this one. All right, so this person did zip codes in the city of Chicago, which there are 41. So they did a cool map here showing all the different ones. And looks like this is the best zip code. And then they sorted the best ones here by the profit. Return on investment is ROI, if you see that. And they just highlighted the top 4 ones. And that's it for that one. I'll give you guys the link to these if you want to see like their code and everything too. Just don't copy exactly what they have, obviously. All right, and then this person did Atlanta. So they have a number of zip codes here. They looked at the seasonality. They did SARIMA. Let's see. Highlighting results. Definitely include a map like this, I think. It really helps it make sense, like especially if you aren't familiar with the area. And that's it for that one. So I will go ahead and send these to Slack channel. And you guys can look at them further if you'd like.
But how do they get the drop down in their readmes?
Good question. I had not seen that before either. I'm sure it's just
It's
well,
taking out to figure out how to. My last one had a decent readme compared to the previous one, and like now I saw that, I'm like, wow, I want that too.
let's see, detail. It looks like it's a details tag. Oh, can you not see this? So this is just the README file. So it looks like those were like this tag here. So like details, I guess. But I'm not sure if you have to have a like a plugin or anything for that. But yeah, it's cool because on the README, it's easy to have like a ton of stuff and